All right, so here we go. We're going to graph linear inequalities. So first what we're going to do is graph the slope. That slope's equivalent to 1/3, so it's up 1 over 3 with forward 3 with a y-intercept of 2. So there, continue the pattern in both directions. Now, if we have this kind of inequality symbol, we get a dashed line. It means we don't actually include the points on the line. That kind of symbol is a solid line. So we have the dashed line, and then we're going to graph the next one. Or now we had a shade. So if the y is less than, we're going to shade down. If the y is greater than, we would shade up. So sorry you missed that there. What I don't like to see is giant shaded region, because we're going to be doing a bunch of these and it gets all messy. So what we're going to do is just shade a little 5 o'clock shadow on that line, and then using the slope and y-intercept, we graph the red line. Again, it's dotted because of this symbol, and we're going to shade below because it's a y less than. If it was a y greater than, we would shade straight up from the line, which means we would have shaded this line, but it wasn't, so we didn't. And now the overlap of the shading regions is the answer. So where I shaded red was the solution for the red inequality. Where I shaded blue was the solution for the blue inequality. So where they overlap is our answer. So that's what I'm going to say. What that means is that any point in here, any point within that yellow shaded region, not including the boundary, would work in this equation and would work if I plugged it into that equation, or inequality rather. All right, so our steps are get to y equals, graph the line, shade the line, and then your overlap is your answer. So for this one, we want to get it into y equals format, and then we're going to graph that, and then we're going to shade up because of the inequality direction, and then we're going to get this next one into y equals format, and because we divided by a negative, we need to switch the inequality. Anytime you multiply or divide by a negative, you switch the inequality. All right, so notice that this is now the other direction, which means I actually have to shade down on this one. So there's my line, there's my shading. The overlap is the answer. All right, next. So do you remember these kind? This is called absolute value. These are the V-shaped ones. So we're going to do this one first. So the slope is going to be whatever the coefficient in front, outside, in front of the absolute value is. This is an understood 1 since there was no number there. And then the vertex is going to be on the origin for the parent function. Now a plus or minus inside shifts the whole graph up or down. A plus or minus on the inside does kind of opposite what you would think. It moves it left or right. So a plus actually moves it left on the inside, and a negative on the inside actually moves it right. This doesn't have either, so we're just going to graph the parent function. Because of the inequality, it's going to be a solid line. Because of the direction, we're going to shade up from the lines. And then this is another little weird one. This is actually a vertical line. And if it was a y equals, it would be a horizontal line. So the vertical line through x equals 2. Dotted because of the inequality. We want x greater than 2, so we shade to the right, and then the overlap is again our solution. So next one, here's the entire process. Shade that. Now because this is a -2, we're actually going to slide the parent function right 2 units. Shading down, it's a solid line because of the symbol. The overlap is our solution. See you next class.